Hi everyone, it's Eleanor from the Clifton Institute. This afternoon I'm going to be working through an activity that we do on some of our field trips all about mathematical patterns in nature. So we're going to learn how to identify shapes in nature, and we're going to learn why some shapes are more common than others. And I hope at the end that you'll feel inspired to go look for shapes in nature yourself. To start with, let's talk about what it means to be a pattern. If you're watching with a friend or a parent or another loved one, you can pause the video and talk for a minute about what you think a pattern is. What I mean by pattern is something that repeats over and over and over again. I'm wearing my favorite patterned t-shirt today. There's a striped pattern that goes red, white, red, white, red, white, over and over again. Do you know any other examples of patterns? How about patterns in nature? Let's look at a few pictures. In this first one, I see a pattern on the raccoon's tail. It goes gray, black, gray, black, gray, black, over and over again. It's striped, just like my shirt. In this picture, I see wave after wave after wave after wave coming into the beach. How about in this picture? Do you see any patterns? I see the same shape leaflets repeated over and over and over again on either side of the fern leaf, and they get a little smaller as you move up to the top of the fern. All of the patterns that we're going to be talking about from here on out are patterns with shapes. So let's make sure we all agree on the names of the shapes. This one, has 3 sides and 3 corners. This is the triangle. This one has 4 sides of equal length and 4 corners. This is the square. This one has 5 sides and 5 corners. It's a pentagon. This one has 1, 2, 3, 4, 5, 6 sides and 6 corners. That's a hexagon. This one has 1, 2, 3, 4, 5, 6, 7 sides and 7 corners. This one's called a heptagon. This one, it reminds me of a stop sign. It has 1, 2, 3, 4, 5, 6, 7, 8 sides and 8 corners. It's called an octagon. So now that we know the names of the shapes, let's look at some patterns. This is the nest of a paper wasp that we found just like this out in the woods here at the Clifton Institute. Do you see any patterns? The pattern I see is the same shape repeating over and over and over again, all throughout the nest. Can you tell what shape it is? If you look at each of these cells or holes, you can count how many sides they have. Let's do it together. 1, 2, 3, 4, 5, 6 sides. That makes them hexagons. They're hexagons being repeated over and over and over again. Here's another paper wasp nest. And if you look closely, you can count the sides on most of the cells, more hexagons. Here's another paper wasp nest, more hexagons. Here's a hornet nest, and if you look closely, or if you pause the video, you can count the sides in there too. There should be lots of hexagons. This one is in a wasp nest. This is the honeycomb from a beehive, and I see more hexagons. Some more honeycomb, and more hexagons. This one's just beautiful. You can really see how well defined, beautifully perfect hexagons are all through that pattern. So we're going to try to figure out why all of these different types of bees and wasps build their nests and their hives using hexagons and no other shapes. So in order to figure that out, we have to know what these different animals are using their nests and their hives for. So you can see in all of the pictures that I just showed you, there were some eggs and there was some honey, and those are the 2 things that different species of wasps and bees and hornets are storing in their nests or their hives. They're 2 really, really valuable resources either honey or eggs that they have to store in these structures. So we're going to do a little experiment, and we're going to pretend that we're bees, and we're going to see if we can figure out why different bees or wasps would want to build their nests with hexagons and not other shapes. Of all those shapes that we talked about before, 3 of them are very special because you can make repeating patterns with them only using the same shape over and over. So you can see here, you can pack triangle after triangle after triangle into a repeating pattern. You can do the same thing with square after square after square. And you can do the same thing with hexagon after hexagon after hexagon, but you can't do this with any other shape. So these are 3 very special shapes, and these are really the only 3 possible shapes that bees could use when they're building their nests or their hives, because these are the ones that they could make the same shaped cell over and over and over again to store their honey or their eggs. So we're going to experiment with these 3 different shapes and see if we can figure out why one might be better than the others. Okay, so we are going to pretend that we're bees, and we're going to do a little experiment with those 3 shapes. And here's everything I need for the experiment. I have a piece of corrugated cardboard. I have 3 pieces of string that are of equal length. Mine are just over 10 inches long, but it doesn't really matter what length they are as long as they're all the same. I have some push pins, and if you want to do this experiment at home, you can ask a parent or an adult for help using the push pins. And I have a bowl of M&Ms. And you can use anything that's small or round. You could use beads, you could use peas, you could use pie weights, anything that's small and round that we're gonna fill some shapes with. So like I said, we're gonna pretend that we're bees, and then today, instead of using wax or paper to build our nests with, we're gonna use string. And instead of filling our honeycomb with honey, we're gonna fill it with M&Ms. So the first thing that we're going to do is make those different shapes. So we're going to start with a triangle. I'm going to try to divide this string into equal thirds. That's pretty good. And I'm going to pin down the corners of a triangle of equal length sides. Let's see if I can do this evenly. That's pretty good. And wrap the string around it. So this would be the cell of a bee that used triangles instead of hexagons in its beehive. Let's see, I put this corner a little too high. There we go. Now let's do the square. So I'm going to divide the string into 4 equal lengths and try to make a square. So there's one corner there. Let's see, I'll measure out this side. One corner there. One corner there. One corner there. And I'll wrap my string around again. And so this is as if a bee were making its cells with squares instead of hexagons. It can be a little tricky to get things lined up just right. How about that? There we go. And then finally, we're going to end with a hexagon. So I have to try to divide this string into 6 equal pieces. And make a hexagon. So I'm going to start with a corner here. Let's see, I'm going to move that over actually. Go up about there. So what I'm trying to do is just make sure that the sides are about equal length and that this string is going to wrap all the way around. 1, 2, 3, 4. Oops, I made these a little too far out. That's okay, I'll just scooch things in. That's a pretty good hexagon. So we've made our 3 different shaped cells for our honey hive, or our honeycomb, or our paper wasp nest. And now we're going to see how much honey we can fit in each of the 3 shapes. So let's start with the triangle. 1, 2, 3. This might be a minute. Okay, so I managed to fill my 3 different shaped honeycomb cells with all the M&Ms I could fit in there. So now we have to count how many M&Ms I could fit in the different shapes. Let's see, with the triangle I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I better write that down so I don't forget. In this one, in the square, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And if you know your multiplication tables, you could have skipped all that counting and just multiplied 5 times 5 to get 25. Now let's count the hexagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28. So of the 3 shapes that bees could possibly use to build their nests or their hives with, hexagons, you can fit way more honey than any of the other shapes.
Remember that I used the same length string for each of the 3 shapes. That's the same as if a bee used the same amount of wax for 3 different shaped cells. So another way of saying this is that the bee would have to use a lot more wax to store a given amount of honey if it used triangular cells than if it used hexagonal cells. So hexagonal cells are just more efficient.
Pretty cool. And you could do this with different size strings, different size M&Ms, but as long as you're using the same amount of string, and remember that's pretend for the same amount of wax or paper and the same size M&Ms or honey drops, you're always going to be able to fit the most honey in a hexagon shaped cell. We figured it out. Wasps and bees build their nests and their hives using hexagons because they can store the most honey and the most eggs, while at the same time using the least amount of paper or wax as possible using hexagons and not any other shapes. It's an amazing adaptation that these little tiny animals have figured out what the best shape is to use to pack their valuable resources the most efficiently. It's just amazing. And next time, once we're able to see each other in person again, next time you're out here, you can come inside and look at this one for yourself. So we're going to see if we can find hexagons now in other places in nature. And it turns out they're all over the place.
This is the close-up of the eyeball of an animal called krill. It's kind of like a shrimp. They have compound eyes, which are made up of all these little tiny eyes packed together. I think I see some hexagons in there, but let's make sure. I'm going to draw around the sides of each of the shapes and count the sides as I go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All of the shapes have 6 sides, so they're all hexagons. There are 7 hexagons in this picture. This is a picture of bubbles in soapy water. I see some hexagons, but I think I see some other shapes too. Let's figure out what shapes are in the bubbles. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. A heptagon. 1, 2, 3, 4, 5. A pentagon. 1, 2, 3, 4, 5, 6, a hexagon. 1, 2, 3, 4, 5, 6, a hexagon. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Some of the shapes go off the edges of the picture, so I don't know for sure how many edges they have. We are counting lots of different shapes. I wonder how many of the different shapes we've found. Let's try to record how many of the different shapes are in the two pictures we've looked at so far.
The way that we're going to record all of those counts that we're making in our different pictures is with a bar chart or a bar graph. So along this axis are those shapes that I showed you before: triangle, square, pentagon, hexagon, heptagon, octagon. And on this axis are how many of those different shapes that we counted. So in the krill eye, we counted 1, 2, 3, 4, 5, 6, 7 hexagons. So I'm going to make 1, 2, 3, 4, 5, 6, 7 boxes in my bar chart for hexagons. In the picture of the bubble, I counted 1, 2, 3 pentagons, 6 hexagons, so I have to add 6 squares, and I counted 3 heptagons.
Let's try counting shapes in some other places in nature. This is a box turtle that was here at the Clifton Institute a few days ago. Isn't it beautiful? I see some shapes in the scutes on its shell. Again, there are some shapes whose edges I can't see, so I'm only going to draw a shape if I can see all of its edges. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
We're starting to find so many hexagons that I had to add a second page to my bar graph. So now we can count all the way up into the 20s. On the turtle shell, we found one shape that had 4 sides. It wasn't exactly a square, but I'm going to add a box above the square, because that's the closest of the shapes that we have on our bar graph. We found 3 pentagons, and we found 2 hexagons. 1, 2. So now we've found a total of 15 hexagons.
Can you tell what this is a picture of? That's right, it's the skin of a pineapple. And if you have one in your kitchen right now, you could go and count the shapes in it yourself. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6.
In the pineapple, we found 1 hexagon and 2 heptagons.
This is one of my favorite pictures of patterns in nature. It's a rock called basalt that forms as lava from a volcano cools, and as it cools, it forms all sorts of shapes. Let's figure out what they are. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Hooray, a hexagon. 1, 2, 3, 4, 5, 6. Another. 1, 2, 3, 4, 5. Back to a pentagon. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
In the basalt, we found, let's see, 3 pentagons. 1, 2, 3, and we found 6 hexagons. So let's see, I'm going to add 1, 2, 3, 4, 5, 6. Let's see if we can read this bar chart together. We found 1 shape with 4 sides. We found 9 pentagons, 22 hexagons, and 5 heptagons. We didn't find any triangles or any octagons. We found way more hexagons than any of the other shapes. Isn't that cool?
The reason that hexagons are in all these other places is the same as the reason that they're in beehives. Nature, just like the bees, likes to pack things in efficiently, and it can do that better with hexagons than with any other shape.
We're learning that the hexagon is nature's favorite shape, and it's my favorite shape too. This would be a really fun activity to go do in your yard or here at the Clifton Institute if you come on one of our open access days. You can go look for all the different possible shapes that you can and then record your findings in a bar chart. Maybe you can even find an octagon somewhere out in nature. I'm going to give you a couple more ideas for places that you can look for shapes. This is a picture of a lichen that I took here at the Clifton Institute. And if you squint, you can see a hexagon right here. This snake's scales look a little bit hexagonal to me, but you'll have to look closely and see whether you can figure out what shapes they all are. This is a picture of a very special fish called the hexagon rock cod, and all of its spots are hexagon shaped. I think that's so cool. So your homework is to go look for hexagons everywhere you can, and please let me know what you find. I would love to see your pictures, or I would love to hear if you find anything cool. Thanks for watching. Bye.